This is problem number 1 from section 4.7. In this problem it says, find all real solutions of the following rational equation and check any results. Now they're going to ask us to check any results because we need to make sure that we don't get any extraneous solutions. So extraneous solutions. What is an extraneous solution? Well, it's a solution that we get that, for an answer at the end, that when we plug it back into the equation actually doesn't work. And that comes about sometimes when we're multiplying by x across the equation. We can essentially add extra solutions that shouldn't be there. And those are called extraneous solutions. They look like solutions, but when you plug them back in, they don't actually work. So let's go ahead and start solving this problem. We've got a fraction plus another fraction equal 1. I always like to cancel the denominators of the fractions to start. So what I'm going to do is I'm going to multiply this entire equation by the common denominator between these two, which is x times x plus 5. X times x plus 5 is the common denominator between these two denominators. So when I multiply it, it's going to cancel this denominator for the x plus 5, and then when I multiply it times this, it'll cancel the x. So it's kind of killing two birds with one stone. So I'm going to split this up so it's x times x plus 5 times 4 over x plus 5 plus x times x plus 5 times 1 over x, and then equals 1 times x plus 5. All right, now you can see here that this is really x times x plus 5 over 1, and this is x times x plus 5 over 1. You'll see that we can cross cancel here, and we're left with just 4x on the left side. We can cross cancel the x with this x, and we're left with plus x plus 5, right? Because when we multiply x plus 5 times 1, and it's over 1, right, it doesn't change anything. Same thing over here, 4x over 1. And then we get equals, on this side 1 times x is x, we distribute the x to each side, and we end up with x squared plus 5x. All right, now we can go, and it looks like we have a quadratic here with this x squared, so we're going to need to solve this quadratic by setting it all equal to 0. So I'm going to combine like terms on the left side, so that's 5x plus 5 equals x squared plus 5x. Now I'm going to subtract 5x over to the right side, and I get 0 here, right, for both sides, so I have 5 equals x squared. Well, at this point, because that canceled out, it actually makes the problem a lot easier, because now I don't have to get necessarily this equal to 0, because if I move the 5 over, I'll just end up moving it back over to solve. So at this point, I can actually just square root each side to get a solution. So I'm going to square root the x squared side, square root this side. That's going to be plus and minus whatever that root is. So I end up with plus and minus root 5 equals x. So my solutions are x equals root 5 or x equals negative root 5. Now, I think those are solutions, but I need to check those. See, notice when we multiplied by the x and the x plus 5 across the equation, we ended up with a quadratic. Anytime you end up with a quadratic, you've got to really watch out that you didn't get an extra solution, which is extraneous. Anytime that you started, I didn't have a quadratic to start with, but I start multiplying stuff and I end with one, usually that's a sign that we could possibly have an extraneous solution. So let's easily type this in using the calculator. If you have a TI-84, makes it slick and easy to do this. So I'm going to take root 5, and I'm going to store it as x. And then I'm going to type in this entire equation. So I'm going to say fraction, and then 4 over x plus 5 plus another fraction, 1 over x equals 1. Well, actually, I'm not going to put equals 1. I'm just going to type this in, and then I'm going to hit enter, and if it's 1, then we have our solution, right? Because I plugged in root 5 for the x values. And I do get 1. So this is a solution. Root 5 is a solution. So now I'm going to do negative root 5. So negative root 5. And I'm going to store it as x. I'm going to go grab this function again, hit enter, and if I get 1 again, then this is a solution as well. I do get 1, so my solutions here are x equal root 5 and x equal negative root 5, and I can say that there are no extraneous solutions. So no extraneous solutions.